A local museum has a special policy. Adult tickets cost $11 and child tickets cost $5. A group spends a total of $55 of tickets. If X represents the number of child tickets and Y represents the number of adult tickets, write a function to represent the situation.
Okay. So let's just kind of break this down. Uh, so we have adult tickets, and those are $11. We also have child tickets, and those are $5. And they also tell us the total cost for a group that spent money was $55. Um, what else do we know? We know that we want X to represent the number of child tickets, and Y is the number of adult tickets. We're going to come up with a function. So this function is going to be for the total cost. So let's think about that. We have adult tickets and child tickets. And which ones are represented? Which variable represents our child? Or I should ask, what does X represent, adult or child tickets?
Child,
Child. How much are the child tickets?
$5.
So the total cost for all the child tickets would be 5 times X, the number of those tickets. And then we also want to total that up with all of the total price for all the adult tickets. How would we get that part of the equation?
Do 11 and do Y.
11y. The cost per ticket for adults times the number of tickets they buy, y. And all of that has to total up to what amount? 55. So we just created an equation in standard form, and it is a linear function. We can go ahead and rewrite this with a little algebra help and create something in another format. But basically, a standard form equation looks like this: ax plus by equals c. And we have certain, we call them restrictions for the quantities a, b, and c. Okay, so for example, a, b, and c have to be integers. So positive and negative whole numbers whose greatest common factor is 1. So I can't divide out anything from these numbers. So for example, if I had 11 and 55, I would still have a common factor of 11, right? But because this is just 5, it's okay. Also, if I just had 5x and 55, what common factor do those two have?
11.
I don't think 11 goes into 5. Yeah. So if I have these two, they have a common factor of 5. If I have these two, I have a common factor of 55. But add one of the other, either 5x or 11y. Not all three of them have the same factor. So this is in standard form. Also, a must be positive. It's not a hard rule, but it does make working with it easier. Once you are working, like I said, in something that uses them, like econ classes and stuff like that. B cannot be 0 because if B is 0, which is a number that goes here, where 11 is, that would just eliminate this. And it would just make a horizontal line, which is not very interesting. Okay, so knowing this is what it looks like, ax plus by equals c. And they have to be integers. A has to be positive. Let's see if we can't find equations that are in standard form, meet all of these conditions. Yes. Yeah, go ahead. So work with your partner and circle all the equations that are in standard form. So make sure to read and understand these. So go through, look at it with your partner and decide which equations are in standard form here. Okay? Let's see if you can find them. Let's see. I'm going to point and just give me a thumbs up, it is standard form, or thumbs down, it's not. So here we go. Thumbs up or thumbs down? Yeah. This is most definitely standard form equation. How about this one? Okay. Yeah, this one we're going to revisit in about a week or so. This is, write this down. This is called point slope form. So just call it point slope form. We'll come back to this one. And there's a reason why it's called point slope form. And we'll get into that, like I said, next week. Okay, how about this one? Thumbs up, thumbs down. Okay. I mostly see thumbs down. That's correct. What disqualifies this one?
A is negative.
Yeah, A is negative. Yeah, this number shouldn't be negative. Okay. How about 2x plus 5y equals 20? Definitely thumbs up, that is. Oh, and sorry, that one shouldn't be circled. How about this one? 3/4 x plus y equals 6. Thumbs up, thumbs down. Okay. Yeah, it's thumbs down. The reason is here. There has to be an integer, not a rational number. So A has to be positive. B can be positive or negative, but it has to be an integer, not a fraction, not a decimal. Okay. How about 7x plus 3y equals 53? All right. So no on that one, no on that one. This one, no as well, but it's a point slope form. Now, the reason we learn about these is it's especially useful for finding intercepts, x-intercept, y-intercept. So let's explore what those are. We already have an idea, but we're going to continue. So the y-intercept is the point where the graph crosses the y-axis. So if we have any type of graph, wherever it touches or crosses the y-axis, it's called the y-intercept. And the x-intercept, also called a 0. And we're also going to be calling that a root next semester. Is the point where it crosses the x-axis. So we have a graph here. Let's identify where it crosses the x-axis and the y-axis. Those 2 points. This is the x-intercept. This is the y-intercept. Okay. And we usually write these as ordered pairs. Bless you. So it's an XY ordered pair. And what we want to do is figure out the coordinates. So what's the coordinates for this point right there? 8, 0. How about for this point here? 0, 6. And one of the things we should keep in mind is when we have an x-intercept, y is 0. And when we have a y-intercept, x is 0. That's always going to be the case. If a line is crossing the x-axis, the y value is going to be 0 because you're at 0 there. If you have a line or graph crossing the y-axis, that means your x value is 0. Okay, so that's the next part. An x-intercept will always have a y value of 0. A y-intercept will always have an x value of 0. And that would really help us in graphing. Let me show you. Okay. So say we have a couple of equations in standard form. And you're going to get so good at this, you could probably do all the math probably in your head, but we'll do it step by step this time. Okay. So we want to find the x and y intercepts, and then we're going to use the points to graph the line. So let's give this a try. So what you want to do, the quickest, easiest way to do this so that you can understand the concept, I'm going to make a quick little t-table. Go ahead and do that. So this is going to be for the x-intercept here on the left and the y-intercept on the right. Now, we're going to use the most important fact that we know to figure out what the coordinates are for the x-intercept. We're also going to use that fact to find the coordinates for the y-intercept. So for an x-intercept, the thing we have to remember is what's the value of y. If we have a x-intercept, what number goes there? Do we already know y has? Y is going to be 0. Similarly, for the y-intercept, we know that the x value is 0. Okay? Like here. So let's go ahead and see what the consequences of that are. So if we know in this equation y is 0, what's 2 times 0? 0. So wouldn't we have x equals 6? Does that make sense? If this is 0, this right here, wouldn't it be x equals 6? See how easy that is? We already know this fact. X equals 6. So now we know the coordinates for the x-intercept. 6, 0. We just plugged in 0 for y. That all goes away, and you're left with x equals 6. Now, let's use that same trick for the y-intercept. So in a y-intercept, x equals 0. So what are we going to have if I replace x with 0? 2y equals 6. So we have to do a little bit of work, but it's not very hard. Because now to solve this very simple equation, divide both sides by 2. And we end up with y equals, not 0, equals 3. y equals 6 divided by 2, so it's 3. So what would the coordinates be here for the y-intercept? Well, what's the x-coordinate going to be? 0. And we just found out the y-coordinate is 3. Okay? Go ahead and plug in those 2 points. Find 6, 0, put a point there, because that's a point on the line. Find 0, comma 3. That's another point on the line, so 6, 0 is right here. 3, 0 is 1, 2, 3 up right there. How many points do I need to know to be able to graph a line? 2, and I know 2. So this is the graph for this line. If you know where it crosses the x-axis and the y-axis, and most lines do cross the x-axis and y-axis, then there you go. Okay. So we're going to try that again for number 2. X-intercept here, y-intercept here. All right, let's do it. Use the fact that on a x-intercept, y equals 0. On the y-intercept, x equals 0. And see if you work with your partner, see if you can't figure out what the coordinates are for each one. Okay, just replace the appropriate variable with 0. Like here, I'm going to say 7 times 0. 7 times 0 is just 0. So my new equation would be, since this goes away, I'm going to have 4x equals 28. Okay. And do the same thing. Replace x with 0 to find the y-intercept. That would get this to go away, and you'd have this equation left. So the zeros eliminate one of the terms, either the x term or y term. And then just write the coordinates. Okay, so what's the x-intercept coordinates going to be? 7, 0. And for the y-intercept, it's going to be 0, 4. Easy peasy. All right, so we have 7, 0 right there. 0, 4 right here. This line has to cross both axes at these locations. Okay. All right, so we're going to do that. We have 2 IXLs. For the second IXL, I'm going to show you on the actual IXL. So we're going to do a quick little group jam. But this one here, we're done. This is what you're going to be doing. They're going to give you equations in standard form, and they're going to ask that you graph the lines.